All right, let's take care of part B. By the way, in the question statement, I forgot to put the limits of the definite integral. So please also consider this integral from 0 to 1. So we have a fraction where the top and the bottom comes with the order 2. Both are quadratic. So this is a good question of practicing the polynomial division. Okay, so let's just first take care of that. So I'm going to divide x squared minus x um, by x squared plus x plus 1. Okay, all right. So this is going to be 1 here, and then 1 times x squared plus x plus 1. And I'm going to subtract x squared plus x plus 1 from x squared minus x. So you have minus 2x minus 1. Okay? So let's just write, because now we're done with the polynomial division because the order of this or degree of this is less than that. Okay, so we stop here. So that means we're done with the polynomial division. So x squared minus x divided by x squared plus x plus 1 is equal to 1 plus minus 2x minus 1 divided by x squared plus x plus 1. Okay? In fact, I can also write this by pulling out this minus here. So here we go. So I can put a minus sign here. So that's going to make my job easy when it comes to integrating this function. Okay. So what do we have? So this integral here is going to be equal to integral from 0 to 1, 1 dx minus integral from 0 to 1, 2x plus 1 x squared plus x plus 1 dx. And all I'm going to do is just to erase the long division because I'm completely done with that. So that was sort of like an auxiliary step to be able to integrate the given fraction. Okay. So now this integral, the first one is relatively easier. So it's just 1 dx, right? And this integral is not. So this is a good u substitution problem, in fact. So on a separate piece of space, so you can go ahead and look at the integral of 2x plus 1 x squared plus x plus 1. Okay. And as I said, this is a u substitution problem, and I'm going to call the bottom to be u because du, as you see, it's just 2x plus 1 dx, okay? Which essentially make this integral equal to du over u type integral, right? And that is ln absolute value of u from the basic integration formulas, okay? And we put the integrating constant. However, we have a definite integral to take care of, so I don't need that integrating constant here. So I'm going to continue here. So 1 is integrated as x from 0 to 1 minus ln of x squared plus x plus 1. And then I'm using, obviously, fundamental theorem of calculus here. So from 0 to 1. All right. So this is 1 minus 0 minus, just put a parentheses here, ln 3 minus ln 1. Okay? And ln 1 is equal to 0. So that takes us to 1 minus ln 3. We can leave it exact, okay? Leave the value exact, so you don't need to use a calculator here, or you don't need to find a number with decimal places. I think this takes care of part B. I think we're done. All right, so thanks for watching. I'll see you in another video. Bye.